How you doing, Mr. Elf? How you doing? How you doing? How you doing today? How you doing today? Let's see. Here we are. I guess I'll go. Oh, she gonna come up and say hello to everybody. Yeah, you wanna come up and say hello to everybody? Why not? Get your butt up there. Yeah, get your butt up there. She can't. She can't. Get a nice view here. You wanna hop up? There we go. How's that? You wanna hang out here? Nah. Where's your water? It's down here. I keep my cat's water on the desk, and if she drinks out of it, my microphone picks it up. It's not a pleasant noise for anyone who's listening. It's just a fun fact about me. Give everybody a few minutes here. We got an easy day ahead of us. Nothing crazy going on. I am going to go black here for a moment because I just want to confirm I'm not showing anything that I don't want to show. Yep, that looks good. That's next. And then that thing, and then that thing, and then that. Okay. You can sit down if you want. Yep, you sit down if you want. Okay. That should be good. So now I'll come back to life here. See if we can make this bigger. I guess we'll do it this way. Yep. No, come back. Okay, and then we'll get rid of this. I don't need to see that. Alrighty. See how we did here. Alright, looks like we got most of the class here today. Time for you to get out of here, Kat. We're going to get started. So, welcome everybody. Does anyone have any questions about stacks or queues? Please let me know. I was a little late in uploading the class code, but I did get to it, so it's up there. And I did make a few edits to it after class, because I did run into that small issue, and so I was just double checking it. But the updated code is there, so you can reference it. That stack and queue implementation is almost exactly like the one that we've done in the assignment here, except there's one difference, and that is how the pop and the push are implemented, like which one is virtual and which one is not. So in the assignment, it happens to be the other way around. So you'll have to do a little bit of thinking, but nothing too out of bounds or nothing too crazy, because we've all done linked list stuff before, hopefully. I am going to spend a lot of time talking about the assignment today. We'll take a good 20 minutes to really look at some stuff, answer some questions, and then we'll kind of end class early so that you guys can go take that ABET exam, which I have up there. It is available for you to start now, but I wouldn't recommend that because there are a few things this semester that I didn't really teach. So at the beginning of a class, I'm going to ask for a little bit of class participation. We're just going to answer 3 questions. Maybe take note of them or not. I don't really mind. And once we get through that, then we'll talk about the assignment, and then you can take that practice quiz. I'll show you where it is and everything. And you don't need Lockdown Browser for it. So to begin, we're just going to answer these 3 questions. And I want you guys to kind of guess here, okay? I don't want to... I should have talked about it earlier. I know for a fact that I didn't. I just want to see what you guys think. And that's it. So to begin... Ooh, yes, do this. Let's say I'm coding a class in C++. Okay, so I got my include IOStream. I'm probably going to use my namespace here. And let's say that I just declare this class student. And that's it. That's all I do. And there's nothing on the inside. There's nothing on the inside of this class. So we did talk about size of. We did talk about size of before. That operator that tells us how many bytes a data type is using. How many bytes do you think that this uses? If there's nothing in here, does anyone have a guess at how many bytes this thing uses? I like both of those, but macros is the winner, actually. He's absolutely 0 bytes. The way that classes are implemented is that here's kind of how they work. It's good that we talk about this. They kind of work like arrays. And I do remember earlier this semester I kind of messed this up. And I kind of fooled myself in front of everyone. I've made mistakes plenty of times. But let's say in this student, I don't know, maybe I'll do a float. Now that's going to be 4 bytes. And then let's say we do an int string, which I believe is 8 bytes. And so kind of what this has to do is in the class declaration, it will store 4 bytes here for the float. And we'll store 8 bytes for the string. Now, up here, it has to store some information. And that information is, where are my variables? What addresses are they at? Because just like with arrays, when we reference this class, it's going to say, all right, we have to find, if I say student.f, it's going to say we have to find this float. So it's going to come to the starting address of the class, which is here. It'll say, hey, where is my float? It will find that address, or rather, how many bytes do I need to add to this address to get to my float? If we're going to access string s, it will say how many bytes do I need to add to my address to get to the string. So that's how classes work. They work like arrays, except because there's different types of or different types of variables and different sizes, it needs to store some information about how far away they are from the starting address. So does that make sense? Do I need to talk any more about that? Nothing like that will be on the test. If it is, I'll throw it on the review sheet, but most likely no. Just remember that the actual declaration, this is 0 bytes, no memory at all. Okay? So that's the first thing that we're going to talk about today. The second thing I completely skipped over, but let's just take a wild guess. So in code, with C++, we have all of these files, right? Notice here with this assignment, we've got all of these files. Come out here. Yeah, look at this. Look at this. We've got the customer, we got the line, we got the store. So at one point, the files have to be compiled. At one point, the files have to be linked. And at one point, the files have to be executed. So in these things here, if we've got E for execute, executor, C for compile, and we've got L for link, does anyone know what order these all happen in? From the moment we start with our program, like say we finished our code, to the moment that we're getting ready to run it, what's the correct order that these things happen? One of them should be pretty obvious. So tpeter and Red Rose say link, compile, execute. Now that's what I would think as well, but it actually happens to be first things are compiled, and then they're linked, and then they're executed. Now the reason this works is that as long as the compiler has access to the headers, okay? As long as that file has access to these headers, it knows what these do. So let's say I'm going to call getNextCustomer from main, okay? And notice that this definition is probably stored in line.cpp. It's probably stored in line.cpp. But just by referencing this header, we know what type it is, and we know that it's just a part of this. And so the code can continue to compile, and then afterwards it can link that address. It will say, hey, I'm going to call getNextCustomer here. And so after everything's compiled, it will then just kind of link that address to wherever it had previously compiled this function to be called. So does that make sense, everybody? Please let me know. Let's see here. Yeah, so the best one for that is probably CLE. CLE. And then the last one, this one's easy. This one's easy. Hopefully. What kind, if we're going to do arithmetic with pointers, okay? So if we're going to do arithmetic, we can really just talk about addition, right? That also includes subtraction if we're adding negative numbers. And we're also going to talk about multiplication. Multiplication, which also includes division. So of these two things, which ones are legal for pointers and which ones are not? Add is correct. So this one, we can always add and subtract two pointers. We've done it, right? I've showed you how to do it. Never are you allowed to multiply or divide an address, okay? So those are the three things we have to talk about. And that's it. Everything else I covered, and it should be good. Now, when we do this ABET test, it's not for points. Just do your best, and it just tells me, where I need to improve. So keep that in mind. And it's anonymous, or I'll make it anonymous. I mean, obviously, you'll submit it on WebCampus, and I'll see it. But when I submit it, it will be completely anonymous. It won't be for a grade. So that's it for that. Now, I will talk about the assignment. I also just forgot to mention that I will be posting a review sheet today for the final. Okay, so you can get started with that. And I also wanted to talk about this assignment in general. So the assignment is on WebCampus. It's worth 200 points because it's like a complete wrap-up for the semester. Where's my PDF? It's probably over here. I've given you until the last Saturday in the semester, okay, the Saturday after finals to do it. I've designed this assignment, so I know for a fact that there's nothing in here that I haven't taught you, okay? And if there's anything that I haven't, such as the time stuff, I've already implemented it for you. So really, you don't have to worry about anything of that matter. Now it's a few pages, and there's not very many pictures, okay? So it's actually less pages than assignment 9, but it might be about the same amount of writing because I just didn't put any pictures in here. But it's only about 6 pages, and it's kind of just a walkthrough, step by step. If you just do it, you'll do it. You know what I mean? It's not like there's anything hidden or designed to trick you. There's also another thing I did for you guys. There's quite a few classes here that have pointers in them. Here's the line class. Notice we've got a linked list that has a pointer. We've also got the store class. Notice that this has a pointer. That's the dynamic array. And the store class also has a pointer. There it is. Now, because I said this in the PDF, I'm so nice. Every one of these classes that has pointers, I went ahead and I did the destructor, I did the copy constructor, and I did the assignment overload operator for you already. So you've been doing them all semester, and now you don't have to do them because I want you to focus on the other stuff, right? We've done this millions of times. So all of these are already done for you. I will say that the assignment operator is not called in this assignment, but if someday you happen to go back and use this code, it will be prepared to be safe. There's one thing I forgot to do here. So if you want to re-download store.cpp from WebCampus, I uploaded a new one last night. But don't worry about it because the code will still work exactly the same. I just had to add in this line here. So if you don't think you'll ever reference this code ever again in your life, then don't worry about downloading the new file. I won't mark you for it or anything. But if you do want to grab these, you can just kind of put them in there. Or you can re-download store.cpp. Other than that, there's no mistakes, pretty sure. I've given you tons of comments, so we'll just kind of talk about all of them. And I'll run the code for you. Okay, if you have any questions about that, please let me know. In addition to that, I said that maybe we could do a WebEx call where we can do a group kind of let's get this done session. Now, many of you will be able to complete this assignment, but I know given this virtual year of, it's been a mess, some of you might get stuck. And I was thinking that we could all, I mean, it'd be optional, but sometime during finals week, yeah, that's probably the best. We could all hop in a WebEx call if you want to come, and we could just ask some questions, and I can screen share some stuff, and we can try to get this last assignment done. So if you're interested in that, I'll kind of put up maybe a poll or a test to see if any of you would be interested in that, and if so, what kind of date we could do that. So keep an eye out for that. And so now let's just talk about this assignment. I know some of you have already looked at it, and I know I already kind of talked about it. But the main idea of this project is to look at stacks and queues. But it is a final project, so pretty much everything that we've done all semester is in this assignment. Pretty much everything we've done. So, though it is just stacks and queues, you're going to need to remember a little bit of everything. And so, simply put, we're just going to test the effectiveness of stacks and queues in an imaginary situation. And so for the fun kind of imagination part, the year is 3000 and nutrition comes in cup form, just like that movie WALL-E. And everyone also loves to give reviews. Every business they go to, they give a review. And it's always X out of 5 stars. So it's either 0, 1, 2, 3, or 5. And because all food comes in cup form, no one actually cares about how the food tastes. It all tastes the same. And maybe it's scientifically engineered to taste as good as it possibly can. So people really only care about how fast they get that food. They only care about how fast it comes. And so this means all customers of that business in our code are going to have an impatient timer, which is the time in seconds it will take for them to give up waiting in line. They'll say, hey, this is taking too long, I'm done. And they'll leave the store. And when they leave the store, they'll give the store a 0-star review. But on the other hand, if the food happens to be delivered within the customer's impatient timer, they will give at least 1 star to that business. It depends on how fast the food comes, though. So here, I ask you to look at an example here. And imagine if, say, a customer, I guess I said user here, but imagine if a customer has an impatient timer of 10 seconds. So if that food comes in within the first 2 seconds, they'll give 5 stars, which is 1/5 times their impatient timer. If it comes within 4 seconds, they'll give 4 stars, and that's 2/5 of their impatient timer. 6 seconds, they'll give 3 stars, which is 3/5 of their impatient timer. 8 seconds, they'll give 2 stars, which is 4/5 of their timer. And if it comes within 10 seconds, if it comes within that impatient timer, between 8 seconds and 10, they'll give 1 star. But anything after 10 seconds, they leave. They say goodbye, you get 0 stars. I don't even want the food. I don't even care if I'm next. I'm leaving. So I kind of just broke this down here. You'll have to code this part, but you just take these time slices and you see where or how long a customer has been waiting, and then that's how many stars they'll give to the business. Okay? And so, as I just described, there's a direct correlation between the time it takes to receive the food and the star rating. My computer died here. My computer died. Are we still here? Hopefully we're all back. You guys can hear me, right? At least 1 or 2 people. Just want to make sure. Thank you, thank you. There's 1 person. All right. So I'm not going to read this whole document. I'm just explaining to you what happens. I'll show you the classes, and then we'll run the code, and then we'll be done. Thanks for hanging in there. So basically, what's going to happen is Pizza Shake's business here believes that the queue, which is a standard line, is the best technique. And this is always how fast food has worked, right? First come, first serve. I said that. What does that sound like? Well, that sounds like FIFO, right? First in, first out. First come, first serve. But Future Burger is like, you know what? I'm going to try a stack. I will see how good star reviews, or like what's the best average star review we can get using a stack. Stacks have never been used in fast food before because they're considered unfair, right? What do you mean the last person to come is the first person to be served, right? So you're going to put code in all of these files. You're going to put some code in customer.cpp, you're going to put some code in line.cpp, and you're going to put some code in store.cpp. Now, I didn't include any of the UMLs, right? Those pretty pictures of the tables that tell you where everything is. And why didn't I do that? Well, you can just come look at it, the header file, right? Look, you can see the node, you can see the private members, you can see the public members. You can even see which thing is virtual here. So you can just come take a look, right? And so I tell you exactly what order you should go in. And so we'll just kind of look at them in order. Starting with customer.cpp, the very first thing you should do is initialize all three of the static variables. Now, why is that? Well, I'll show you. So say you come to Bobby, and you're in your favorite directory, and you're ready to, work backwards. I know a lot of you like to do that. I do as well. You work backwards from the errors, right? And so this code will compile, except not at the beginning. So let me show you. And the error it produces is disgusting. It's not a fun error. You'll look at it and you'll be like, I'm not even going to try this. Well, I'm here to show you now. So all you have to type is make. And, whoa, we get this scary thing. Get this scary thing here. So all you have to do is initialize those three static variables. That's it. That's all you have to do. You know what? I'll even do it for you real quick, but I'm not going to show you because you have to remember how to initialize your static variables. So just give me a moment. Well, I quickly throw that in there and compile the code, and then I'll run it. I'll show you what it looks like. Where am I here? So that will go in here. Save it, and then I'm closing it so you can't see it. And then I'm going to load it onto Bobby. And then I'm going to reopen it and re-delete it. All right, so we're back. We're back. So it's this part here. Look, I said do this first. Just initialize all three of your static variables right here. And once you do that, let's try the make again. Oh my gosh, it works. And so let's run it. Let's just run the code, ./a.out. And it asks you, how busy do you think the store will be today? So every second, either 0 up to a certain amount of customers will enter the store. It can be any number between 0 and 100. 100 will be ridiculous, but since the code's not working yet, let's just type 100. And you'll notice every second it will just print this little thing. Nothing is happening, but the timer is going off. And so now that your code works, you can do everything else. Kind of like I said, you can work backwards from errors if you'd like. So just do that first. And your code will always run for a minute. Just 1 minute. I wouldn't recommend changing it because all of the timers are based off of that. But you could if you didn't want to wait. So the next thing you should do is just follow these instructions and code up the impatient, is impatient. And you should also code up the get star rating. This stuff is already included for you. So just do these two things in customer, and then customer will be good. And then the next thing I tell you to do is go to the line.cpp class. Didn't we already do something like this? Yes, we did on Monday. I pretty much did all of these functions except for maybe allocate node. And notice here that getNextCustomer is considered to be the pop function. This one is not virtual. I also said it's similar to assignment 9 function, so you have a lot of reference there. You'll have to code this function, This one might be the most difficult function of the entire project, but I believe in you. And so I'll talk about that, is check for impatient customers. Let's just look at that line file. So what do we have here? We got a get size, you can do that. We got a clear list, you can do that. Allocate node, you totally got that. This is our pot function. And then look here, this one is our check for impatient customers. So pretty much what you have to do is go through the linked list, find any customer who is impatient, and remove them from that list. Because you don't want to serve them. They're going to leave before anyone gets served. So in here you'll have to print some messages, and you'll also have to keep track of how many customers are impatient. Let me close this, I'm sorry. You'll have to keep track of how many are impatient, because then you'll return that number at the end. So I said, for example, if there are 3 impatient customers, you're going to print 3 boo messages. 3 nodes will be removed from the linked list, and number 3 will be returned. Okay, you can totally do this one, but that might be the hardest one in the assignment. Look at this. I did these 3 things for you already. And then down here in the queue and the stack, you will have to do the push function. So in the queue, you'll have to push the customer somewhere so that it acts like a queue. And in the stack, you'll have to push that customer somewhere so that it acts like a stack. Okay? That's it. So you do those 2 things, and then finally you'll come to the store. Finally, you'll come into the store class here. I'm making you do a dynamic array. We've done thousands of dynamic arrays in this class, maybe not thousands, but you have plenty of references for this, 100%. So I'm not going to talk about this, okay? You guys can do these. It's in the notes. It's in your homeworks. You've done this before. And I even did this stuff for you. So just make sure that you do that. Now, this dynamic array is used in the store to store the ratings, right? So traditionally, we might use a vector. But in order to calculate the average rating a store will get, we need to store it in some dynamic array. Instead of using a vector, I want you to prove you know how to use templates and you know how to use dynamic memory. So you're going to make this dynamic array class. And that's where the store ratings are stored. Here we're using virtuals, right? So either the store uses a queue or it uses a stack, right? So we're using a pointer to the base class. And the derived classes will have different implementations of the same function. So there's your virtuals, right? And in the store, you actually only have to do these 4 functions, which are all pretty simple. Just follow the instructions. Serve customer is maybe the largest one in this class. So we'll just talk about it real quick. For the serve customer, all you have to do is first clean out all the impatient customers. So call, check for impatient customers, to make sure that all of the impatient customers leave the line so none of them get served. Make sure to save the value it returns so that you can add that many 0-star ratings to the rating array. Then you'll check to see if the line actually has people in it. And if it is, go ahead and serve that customer. Now, there's no exchange of food. We're just assuming that the store served them. So all you have to do is call getNextCustomer and then get their star rating. And that is the equivalent of serving a customer. And you're only serving 1 at a time. And lastly, if the line size is 0, just print a message that says so. Say, wow, there's nobody in the line, so you know. And that's it. So that's all the code, pretty much. You just have to do those. Main, I already did for you. Now, your VS Code's probably going to give you these red errors. It's because of this. It's because of this library. You can ignore it. You can ignore it. But this main is super easy, right? Look, we've got 2 stores. I'm asking you how busy it's going to be today. And then I do all this time stuff. and then I say while time is less than 60 seconds, basically. And so we'll add some new customers to the stores. They will serve one customer each, and then we'll wait for 1 second. And that at the end, we're going to say, hey, who had the best average rating? And that's it. Okay, you've got a make file here. Already did it for you. So I'm going to run the code now a few times to show you how it works. And before it finishes, I'm going to stop it, because at the end, I ask you to tell me which store did better based off your results. Maybe I'll just do the 0, 1, and the 1, 1. The words. Do you guys have any questions so far? It seems pretty straightforward, I think. At least I think. But I'm the instructor, you know, I'm biased. So I'll run it here. And so let's just start with 0 customers. 0 customers will come in the store every second. So look, it says, hey, the line is empty. The line is empty. The line is empty. So it will run for 60 seconds. And then at the end, it will say, here is our average rating. Now, because no one's actually coming into the store, the average rating will be exactly the same for both of these stores. In addition to that, I've given you, these are on Web Campus, but these are a bunch of sample outputs. So you can actually see what the sample output will look like roughly if we've got 4 customers per second. You'll see what the customers say. As we scroll down here a little bit, you'll see that someone's starting to give 2 stars. Some people are leaving the line. This guy's like, yeah, I've got super fast service here. And so you'll see that it runs for all 60 seconds. And at the very end, I hit it. Look, it's getting kind of getting crazy towards the end. And once we get down to the very bottom, you'll see that I edited it. I said I took these out because I want you to find them out. But so look, here we can check, and you'll see that their average rating was not a number. I think that might be because I divided 0 by some value. I think I divided 0 by 0 here, right? So we'll do one more run with the 1 person per second. Now this one is obvious, roughly, because everyone will get 5 out of 5 stars, right? 1 person comes in, they can be served immediately. So you can see that sometimes nobody comes in, and sometimes someone comes in, and you'll get super fast service, 5 stars. That's it. I'm pretty much done with my spiel here. Make sure you run Valgrind to make sure things are working with no memory leaks. If you're confused about a Valgrind output, you can send it to me and I'll help you find your seg fault. I know I've done that for some of you guys before. It might take me a few minutes because I'm not the wizard. So while this finishes up, I do want to end class early today. I want to give you a little over 30 minutes. I did tell Red Rose that I would talk a little bit about the differences of C++. So I'm just going to show you a link on Geeks for Geeks. I'm sorry that I didn't take more time in depth. But after I finish this, then please take the ABET, and I will see you maybe in the Web Campus call. But we'll get to there when we get there. So maybe I'll post this here in the Discord for Red Rose and anyone else who wants it. And you can see all the different C++ versions here. And C++ 11 is the one that we're working with. And the main things in here are, oh look, we've got delegating constructors. That's the inline method. That's the inline method. Null pointers in here as well. And so this is the one that we use. And now as you come in here, there's a few things you're like, what is this? Polymorphic lambda functions. You'll get into that later. Digit separators, that sounds like something we can use. Variable templates. So what templates have we used before? Templates for functions and templates for classes. What about templates for variables? So that's in C++ 14. Looks like they added some more types. In C++ 17, they've added some of these things. Fold expression, some more types, and a new selection statement. And then I think this one has been released, but I'm not sure. I know that the newest version of C++ has been installed on Bobby and Sally, I'm pretty sure. So you can use these compilers. And the best thing that we should do to adjust our teaching is maybe to talk a little bit more about things that we'd use, such as variable templates. But then other than that, you get pretty much all of your knowledge from C++ 11 anyway, besides maybe a few nice things, because we would never use polymorphic lambdas, at least in CS202. So that's that. My less than satisfying spiel about that. And here you can see that both the stores got 5 stars. Thank you, Red Rose. So that's it. Thank you for being in my class this semester. Thank you for coming to class every day. Thank you for working with me, asking me questions, giving feedback. You can still give me feedback. Submit your teacher reviews. You can tell me, it's anonymous, right? But you can tell me how bad you think I am or where I could be better. I'd appreciate it. I hope you got something out of this class. I hope you had, a good semester. And, that's what I got. I appreciate all of you. I'm still available for messages until next week on Sunday after the assignment's done. I'll submit your grades shortly after that on a Wednesday or a Tuesday. What else? Review session will go up. I'll also put a little poll up to see if anyone wants to do a group session for the assignment. So we can do that. But that's pretty much all I got. So if you don't have any questions or any closing remarks, you can go get out of the stream and take that ABET exam. Please take the ABET exam. No points, right? It'll be anonymous, I promise. Yeah, and that's all I got for you. Thank you once again. I had a great time this semester. Hopefully we can all be in person in the fall. I guess I'll hang out here for a few minutes if anyone wants to ask any questions, but you're free to go. You're welcome. You're welcome. Thank you for being in the stream and asking questions. Hope you guys have good finals. I hope you guys have a wonderful summer. Someday I might see you on campus. Feel free to say hi. If you're still in the stream, I'm very tall, by the way. I'm like the tallest guy in the computer science department. So if you ever see me, you can't miss me. Go ahead and say hello if you'd like. All right, I'm going to cut the stream now. Come talk to me in office hours if you'd like.